Okay, so we're gonna take a look at page 18. So this is like the final page of our booklet. Last two examples. So it says here, sketch the graph of that. Okay, great. So, how do we sketch that? Well, first of all, let's factor. Can we factor the denominator? The denominator is x plus 1, okay. Okay, now you're kind of like, oh, maybe not. Yeah, because you, yeah. Our mind is trained for difference of squares. that's why I said this is a little bit tricky.
I just have a question.
Okay.
That when we in university, maybe they're gonna do something, or always it's gonna be like that. And maybe problems today, we go into math, we will do something
Like factoring?
Yeah.
Yeah.
Okay.
There's other ways of doing this.
Maybe in university
Yeah.
or something.
Yeah. There's different ways of graphing, but this is one way that we're gonna do it. Okay. So yeah. Tricky one because it's not difference of squares. So this one here is not factorable. So not factorable, that means the denominator can't be 0 at all, right? So I'm just going to show you that there's no non-permissible value. If we go x squared plus 1, thank you. If you have x squared plus 1, is there a number for x that will make this 0? And that's equal to 0. So bring this to the other side. X squared equals to -1. And then when we square root both sides, and we're going to get the square root of a -1, which is a undefined, not real solution, right? So there's no non-permissible value. That means every x value is permissible. Okay? Is no non-permissible value. So it's like a double negative. So that means all x values are permissible. Okay, great. Great. So that means no vertical asymptote, right? Because all x values are okay, so that means no vertical asymptote. No, I'll just put VA, none. Okay. Okay, well, if there's no non-permissible value, then there's no hole, then there's no vertical asymptote. Let's see if there's a horizontal asymptote. So is there a horizontal asymptote to this? Okay. The degree of the numerator is less than the degree of the denominator, so horizontal asymptote is y equals to 0. Okay, good. What about the x-intercept and y-intercept? So let's do the y-intercept first. So if we find the y-intercept, what do we need to do? Set x equals to 0. Okay, yeah, you're just very fast. Yeah, it is 2. Yeah, so 2 over 0 squared plus 1. You guys are just sharp. 2. So y-intercept is 2. What about the x-intercept? X-intercept. Okay, so if we have x-intercept, x equals to, y equals to 0. Okay, this is going to be a weird one. How do we do the x-intercept? So y is 0 equals to 2 over x squared plus 1. And then we're going to cross multiply that, and then we're going to end up with 0 equals to 2, which is completely not true. So there's really that shows you that's no x-intercept, right? Because it's not a true statement. Yeah.
Yeah, you can also kind of take a quick route since the horizontal asymmetry for the 0 can't be an intercept.
Yeah, until we get to this one later. Yeah, that's true. Yeah. Okay. The next one, there's like an anomaly there. It just breaks the rules. Okay, so what do we have so far? No vertical asymptote to deal with, but there's a horizontal asymptote at y equals 0. So let's do that. Okay, so that's my y equals 0. Y-intercept is 2. There. Okay, so far, what happens here is that...
You see y-intercept is not.
no, y-intercept is 2. X-intercept, none. Okay, so the point is there. Well, how is it going to behave as we go to the left side and then to the right side? Okay, let's see. Let's imagine this. If you pick a 1, what would happen to the denominator? It's going to be 2, and then 2 divided by 2 is 1. What if x is negative 2? Okay, it's going to be negative 2, so it's going to be 2 divided by 5, so 2/5. Okay, and let's see what's happening there. If we keep going this way in x, if we square that, the denominator will always be positive, right? The denominator will always be positive, but it gets really big very quickly. So 2 divided by a huge positive denominator, it's gonna end up with a gotta be careful. Like that. Okay. Good. Now what about the other one? If we pick 1, it's exactly the same thing, right? If we pick 1 here, that's going to be 1 squared is 1 plus 1, so that's 2. 2 divided by 2 is 1. And then the same thing on this side. As you can see, the denominator stays positive. So this overall function, the y, will always be positive. And then this is the graph. And then you're probably thinking, oh yeah, that's not the typical one that we normally see, right? But it's nice to discuss that. Okay. Yeah.
Why you just denominator in this case?
Come again?
Why we don't factor the denominator in this case?
Oh yeah, because the denominator is actually not factorable. Okay, so So the denominator is factorable because it's not difference of squares. Yeah, it's a sum of the squares. Okay. Is that okay? Did I answer your question? Good. And let's take a look at the last one. Last one. The denominator will always be positive in this one. Okay, is there anything that will make the denominator 0? Is there anything that will make the denominator 0? No, nothing, right? So let's just kind of show that non-permissible value. X squared plus 5 is equals to 0. So x squared equals to negative 5. Take the square root. X equals to the square root of negative 5. So there's no solution there. No vertical asymptote. And no hole. No vertical asymptote and no hole. Good. Is there a horizontal asymptote? What do you think the horizontal asymptote is? The degree of numerator is less than the degree of the denominator. So that tells us y is equals to 0, right? Okay, so that's our horizontal asymptote. Horizontal asymptote is that. Great. What else do we need to do? We need to figure out the x-intercept and y-intercept, right? Okay, so let's do y-intercept. So to do the y-intercept, we set x equals to 0. Okay, so let's do that. Do you have the answer already? Okay, 0 minus 4 over 0 squared plus 5. So y is equals to negative 4 over 5. Negative 4 over 5. So it's negative point. Oh. You know what I'm thinking? It's negative 0.8. That's why I'm thinking, and I ended up putting 8. Okay, now what about the x-intercept? Set y equals to 0. Okay, so set y equals to 0. So set y equals 0. 0 is equals to x minus 4 over x squared plus 5. You cross multiply that, so 0, x minus 4, so x equals to 4. Oh, okay. Now you're probably thinking, it's kind of weird. Isn't it kind of weird that we have a horizontal asymptote in here, you have horizontal asymptote there. Y-intercept is negative 4/5, negative 4/5, so it's negative 0.8, so right there. And then, this is where the kind of the anomaly was like some kind of like so weird. Okay, we said that horizontal asymptote is y equals to 0. But yet, there's an x-intercept at 4. And then you look at the x-intercept of 4, it's not the non-permissible value, so they're not contradicting themselves. So they're saying there's an x-intercept here at 4. Yeah.
Would there be like a hole in the asymptote?
No. Okay, so let's just see what happens in here. Okay, let's start picking. Yeah, this is why I said this is like a controversial one, and people are probably gonna say like, wait a second, asymptote shouldn't cross that, and you're gonna be, yeah. This is one exceptional behavior. Okay, what happens when we have, if we pick any values to the left of the what do you call this? The y-axis. Okay, what happens over here if we pick a number that's like -1? What happens when x is -1? Okay. Let's see. Okay, so if we keep picking a negative value, then the numerator will be negative, yeah? And if we keep picking a negative value, the numerator will be a positive, right? Because the x squared. So overall, we're going to have a negative divided by a positive, which is a negative. So we're going to, as you continue this way to the left, x values are negative. It's going to be, overall, it's going to be a negative value. And it's getting closer and closer to 0, right? Because the denominator gets super big faster. So that kind of gives us, okay, let's put a value here. If x is equals to -1, what would the y value be? -5 over 6, right? So -5 over 6. -1, -5. How did I pull that out? So this is x is 0. Now we're gonna pick x of -1. So y equals to -1 minus 4. -1 squared plus 5. Yeah, okay. So that's -5/6. Okay, -1, -5 over 6 right there. Okay. What if it's -2? What would it be? What if it's x is -2? -6 over 9. Yeah. Okay, equals -2/3. It's going to be -0.6 repeating, right? It's going to get closer and closer, and gets closer and closer to the asymptote that way. Gets closer and closer because the denominator gets bigger and bigger. Now if we pick 1 on the other side, what would happen? If x is 1, what would happen? Y equals to -3 over 6. So it's going to be -0.5. So 1 and 0.5. If x is 2, what would happen? If x is 2, that would be -2 over 9. Yeah. So that's going to be -0.2222 repeating, right? -3. It's going to get like this. And then it's going to cross the x x-intercept at 4. And there is no disagreement between x-intercept and non-permissible value. So that's why it's going like that. Now this is the behavior. What about 5? When x is 5, what would happen? Okay, if x is 5, one over 30, it's going to be 1 over 30. And, oh, it's positive this time. Okay, positive this time. 1 over 30, so it's pretty tiny right there. And then as we keep increasing the x, it's going to start to get closer and closer and closer to the asymptote again. So this is kind of the weird one where it says like this, crosses this x-intercept, and then after that, there's no more crossing. It's going to be getting closer and closer to the asymptote. So this still is still an asymptote because as it continues to the left, it will be getting closer and closer to the asymptote, and it continues to the right, it gets closer and closer to the asymptote.
This is pretty rare in the world of calculus, or is this going to be pretty common?
Yeah,
Why do you take this, the x-intercept? Why do you take intercept? It's because we don't have the horizontal asymptote, or not?
yeah, there is a horizontal asymptote, but
Vertical asymptote.
no vertical asymptote. These two, there's no disagreement between these two. Whereas the other one, this one here, we figured out, okay, that's, you're probably thinking like, when we looked at example number 3, we said, hey, the x-intercept is -1/2, but then when we go to the non-permissible, it's -1/2. So there's no contradiction there. So it's still non-permissible value even though we calculated that one. Okay. Because when we look at this one here, when we cross multiply, we're really solving, we're only solving for the numerator. Thank you so much. We're only solving for the numerator, right? So it looks like this never happened. So there's going to be this one here. There's a contradiction, right? We said that it's x equals to -1/2, but this one here, x, the -1/2, is a non-permissible value. This one, no contradiction at all. Okay, because we said we solve for x-intercept, and then it's nothing in here contradicts that.
It says no non-permissible value.
Yeah, no non-permissible value for x.